Hello everyone. Today we will continue to talk about topic 3, arithmetic for computers. And today the arithmetic operation we will focus on is multiplication. This corresponds to the section 3.3 in your textbook. You are required to read the corresponding material in your textbook in order to get better understanding about the material we delivered in class. Before we talk about how the computer to implement multiplication, let's think of how we implement or calculate multiplication in our primary school. Okay, so what we do is, let's show as here. Right, let's assume we just try to implement the decimal multiplication, okay? So we assume our decimal digits only has 1 or 0, okay? So basically now is I want to implement the decimal multiplication between 1000 and 1001, right? So how you do it? So I believe, although I learned this thing in China, but I think the method is unified in internationally. Okay, so what I do is, right, I try to using, let me make it larger. Okay, so I try to using 1, right, beginning from the least significant digit, which is 1, right? So first I want to say this one we call the multiplicand, right? Just and this one called what? Multiplier, right? So basically, I beginning from the least significant bit of the multiplier and use that digit to times multiplicand. So let me just say, right? So that will be 1 times, right? This is the digit I want to do now. So 1 times 1000, which get 1000. Okay, let me. Right? And then after that, what I do, I need to make sure after using 1 times 1000, this product need to be aligned with the digit in the multiplier I use to calculate the product. Let me say one more time. So if just think we try to do the multiplication as we learned in primary school, right? And then we try to do the multiplication of the decimal number 1000 and 1001. Okay, so 1000 is the multiplicand, 1001 is the multiplier. And I'm beginning from the least significant bit of the multiplier and using that digit to times multiplicand. And I will get the product is 1000. And I will put that 1000 as the location which aligned with the position of the digit in multiplier used for calculated products. Basically, the least digit of this product should align in the same position as the digit I used in the multiplier for the product. Okay, so after that, I will move to the next digit, which is 0, and using this digit multiplier to times multiplicand. And then I will get the product as 0, 0, 0. And again, this product will align with the position of that digit. How I align? Make sure the least significant bit of this product aligns the same position as the corresponding digit in multiplier I use to calculate the product. Okay. After that, I will move to next digit in the multiplier. Let me just change another color to make it more straightforward. Just this one. Okay. And then that means I will get a 0, 0, 0, right? Again, I will align this one to make sure my least significant digit of my product align at the same position as the digit of the multiplier, right? and then I continue with the last digit, right, which is 1. So I using this 1 times 1000, right? And then what I get is 1001, right? I need to make sure I align that, this product, and the least significant bit of this product has the same position as the digit in multiplier, right? After doing that, I will begin to calculate summation, right? So here you can see here is a 0, right? So here, sorry, let me just delete this thing. So that means what I get is 0, right? And then 0. And then here is what? Here is a 0, right? And here will be, this one will be 1, right? So I should align better. So it will be 1, sorry, 1, right? And then, sorry, here should be 0. Sorry, let me see. Because 1 times 1000 is 1000, right? So here's 1, and then will be 0, and 0, and 1. I should align better. Should be in this way, right? So this is how I get that. What we get is I just add all those, the products achieved by the each intermediate step together. I will get this, and this is the final value or final product when we calculate 1000 times 1001, right? Just think what we do. What we do is we're beginning from the least significant bit of my multiplier, and based on this 1 or 0, I will decide whether I will copy the multiplicand or I just leave them as an odd 0. Odd 0 means will not have any impact on the final product. Besides the impact is I do a 1 shift to the left, right? So in other words, that means I summarize basically at beginning from the least significant bit of the multiplier. If it's 1, I will copy this multiplicand. Otherwise, I will shift this the another results, another the product, intermediate product to the left by 1 bit. So overall, what I get is 2 steps, right? Decide copy or not. Another is a shift. And then I will add all the things together. So one thing you also observed, if, I just mentioned here, so if you have n bit for the multiplicand, n bit for the multiplier, the product, you need to make sure your hardware can support n plus n bits in order to make sure there is no overflow occurs. Okay, but what I said here is under assumption. That assumption is I assume the multiplicand and the multiplier are both unsigned. So why I can have this assumption? The reason is, let's just say, again, go back to our, what we learned in our primary school. If you calculate the x times y, okay? So if you know the sign of x, means whether it's a positive or non-negative, whether it is negative or non-negative, and I know the sign of y, means I know y is negative or non-negative, I should be able to know the sign of the products, which is the sign of z, which means whether z is negative or non-negative before I calculate the products. Let me say one more time. If I know the sign of the multiplier and the multiplicands, I should be able to know the sign of the products before I even implement this multiplication. Therefore, what I can do here, in order to simplify the multiplication hardware design, I can first take off the sign of x, take off the sign of y, and then I just assume x and y as an unsigned value. And then I will do the unsigned multiplication. After I calculate the unsigned products, I will put the sign back. Just to give an example, if x is negative 2, okay, y is negative 3, okay? So what I do is I can know before I implement, I know z is a positive number, right? And then after I know that, I will calculate x star and y star, and I calculate the multiplication or the product, let's say multiplication, between x star and y star. And then we get the product z star. After that, I will add the sign back to z star and then achieve z. So here I know the sign of z is positive, right? So that means actually z star is equal to z. I hope this is clear. If this is clear, if assume you understand that, that means I know I'm able to implement unsigned multiplication and add the sign back. Therefore, in the following class, we only focus on unsigned multiplication. So let's see how we really do unsigned multiplication. So let